Hello, everyone. With Halloween being right around the corner, I'd figured we'd go ahead and create a program to commemorate some of those traditional Halloween festivities. So, we're to create a program where trick or treaters knock on a door 3 times, then ask the homeowner trick or treat. And based on that response, either they add a treat to their bucket or they display a random trick out of a list. After that, we'll ask the trick or treater if they're tired yet, and if they're tired, we'll head home and display that total amount of treats that they got while they were running from house to house. We're going to need, just based on this description here, a couple different modules. The first one that we're going to end up using is random. This will allow us to randomly select a trick in the event that someone selects that. So we'll want to import random. We won't use that just yet, but let's get started with defining first that sequence that we're going to have repeated again and again for knocking on the doors. And we want those to not really function in any sort of particular way, but we do want them to have to knock 3 times. And to simulate that, we're going to use blanket inputs. So I'm going to define a function, and we're going to call this knock knock. And let's just create some input statements here. We'll end up calling this later in our main function. So this being a text-based game, let's specify to the user, press any key to knock. And because the question says knock 3 times, we're going to do the same for a couple different inputs here. The next one, just so it's different, we'll say press any key to knock again. And lastly, we'll do one more, press any key to knock a 3rd time. And this function, when we call it with its name, should prompt the user to enter 3 inputs there, and then move forward with the instructions for answering the door. The next function that we'll want to define is one for handling that scenario where the user gets to trick or treat. So we're going to want to pass in some kind of input. For this, we can really name anything, but for now, I know it's going to be a decision, so let's just put decision as the name of our argument. We're going to need to store the number of treats, and to have access to it outside of our function that we just call it in, we're going to want to store it as a global. So we're going to do that using the access identifier global. We'll say global number of treats up here on line 11, right underneath our imports. So based on this decision, we're going to want to do something. First, we're going to eventually want to modify that number of treats if the user does select treat. So let's put in our global so we have access to it. We'll say global number of treats. Underneath that, just to handle some case sensitivity, we want that decision, whether they select treat or trick, we want that decision to be translated into uppercase. That way, we don't have to deal with case sensitivity, as some people might type it in lowercase, some might type it in uppercase. Then we'll want to have our conditional block. We'll say if the decision is equal to trick, in all caps, then go forward with the trick instructions. Else, if that decision is equal to treat, in all caps, we'll want to go through with this second instruction set here. And lastly, this would be the treat instructions. And lastly, we would want to have an else for any of those other cases. In that case, we would want them to have to put in another question, and then based on that question, recall our function. So what we'll do is we'll set a second decision. So we'll say decision equals input. And inside this input, we'll say trick or treat. This will store whatever the user enters into decision, but we're not done yet. We want it to call our function yet again, so it starts from the very top, and we'll call it and pass in our decision. So now we have to define the instructions for what our treat is going to do and what our trick is going to do. Our trick's a little more complicated, because if we look here, we want to say, based on the response, maybe they're going to add a treat to the trick-or-treater's bucket, or display a random trick. The keyword here is random, hence why we imported this there. Random, it's going to be something that's randomly displayed in the console. We'll probably want to use a list for this, so let's go ahead and define that on line 24. We'll define our list of tricks, so we'll say tricks equals, and then our empty list. And inside our list, we'll have, let's start with 3 different tricks that this trick-or-treater might go and do. For the first one, let's do you return later and place a ton of fake cockroaches around their house. And for the second one, we'll do you return later, knock on their door, and jump out of their bushes, scaring them. That's a classic. And lastly, let's do one that's a little bit more modern. You attach a witch figure to your drone. Maybe this trick-or-treater's a little bit more technically inclined. And fly it around their house, traumatizing them. That's probably enough for 3 random tricks. You could always add more to them. Just make sure that each one of these elements is separated by commas. And we're not done yet. Now that we have all of our tricks placed in a list, we're going to want to display them. And we're going to do that by calling our print method and then selecting a random choice. So we'll call random.choice and pass in the name of our list, which is tricks. This should handle this case right here, where if the user decides to go forward with a trick, it initializes this list and then chooses a random element from that list. This means that it will be different every time. Maybe this trick-or-treater only has 3 tricks up their sleeves, but you can always add more. Next, we'll want to handle the treat instructions. And these are going to go hand in hand with our global number of treats up here. We want to make sure that that is accessible later on when we decide to create another function after this for going home. So let's define the instructions here for this. For now, let's just actually print out a treat is given and added to your bucket. After that, let's iterate on our number of treats, saying number of treats plus equals 1. This will add 1 more treat to our bucket. And I think that's it for this decisions for trick-or-treating. It'll go and when we call it, we'll call it in an order that makes it seem as if we're playing a game where we're trick-or-treating. Next, we'll want to define our go home function, and then we'll do some Pythonic tricks to make sure that all of these instructions take place in a sequential order while the user is playing this game. So they theoretically could go on trick-or-treating for hours, and just when they're done and tired, they select no and break out of the game, displaying a message that they've gone home and the number of treats that they've received along their journey. So to do that, we're going to define another function similar to this one. We're going to pass in a decision. So we'll say def go home and pass in our decision. And if decision.upper is equal to yes or y, we'll use the classic y or n in these scenarios, we'll want to jump back to our main function, which we're going to define now. So let's define our main function, and then we'll define something that calls it. First, because this is a game, we'll want it to run indefinitely. So to do that, we're going to use a while loop. We'll say while true, and then we're going to pass in our instructions down here, starting with the knocks, because that's what happens first. The trick-or-treater knocks on the door. So this will go and call our knock-knock function, going forward with input 1, input 2, and input 3. The user will then move on to the next part of the scenario, where they're faced with a decision, and we'll have to define that decision. So we'll say decision equals input, trick or treat, and then we'll pass that decision into our trick or treat function. This will take in the trick or treat decision from the user, pass it into this, make it uppercase, decide whether or not it's a trick or a treat, and go forward with whatever the instructions are within those decisions. If the decision that the user enters in down here is not a trick or a treat, they'll be prompted again, and that decision again would be passed into the function to go through with all those instructions again. This would keep going if they indefinitely entered in things that weren't trick or treat. So think of that as a little bit of fault tolerance for our program. Next, after that instruction there, it's going to come back to this main function. So we'll want to have another type of decision, one for if it's tired, if the trick-or-treater is tired. So we'll say, do you want to continue trick-or-treating? Y or N. We'll then take that decision and pass it into our go home function, which we haven't really defined yet. But we're to pass in that decision, which is going to be tired. Notice we named this decision tired, so we have to pass that right into our go home function. And that decision that comes into our go home function will either be a yes or a no. If they want to continue, this is easy. We just want to jump back to the main function, so we'll call main again, and that'll continue on as intended. But we want to handle other cases too. Let's add an elif. And if the decision.upper is equal to n, we want to go home. So we're going to print out you're tired and go home to count your candy. Your candy total is, then we'll take our number of treats, and because this is stored as an integer value, we want to store this as a string in this statement, so we'll convert it into a string so that we can add it to our sentence. Then we'll just add a period at the end of the statement so that it's easily defined as a sentence. Next, we'll want to have our else statement for any other case, and this will simply be reprompting the user and then passing in that value. So we can actually go down here to line 52 and 53, copy that section, paste it here, and this will handle any other case that the user enters in, if they, in the case that they enter something that's not a Y or an N into that input there. But we're not done yet. We still need to have something that starts our game. If we reran this, it wouldn't know where to start because we're not calling any of these functions that we've defined. To do this, we're going to define a little line of code, that's Pythonic. It says if the name is equal to main, go forward with these instructions. So this will be the starting point when we decide to run our program. The first thing that we'll want to do here is set our numbers of treats equal to 0 so that every trick-or-treater that plays this game will start with a 0 for their number of treats. After that, we're just going to want to call our main function and we're done. What this will do is go through with all of these instructions here indefinitely until the user breaks out of the game. And they'll break out of the game once they're done and they say, go home, you're tired, and saying that they don't want to continue anymore. So let's go ahead and run this and play the game. Press any key to knock, so we'll knock once. Oh, we'll knock again, and we'll press one more time to knock a third time. Now we'll do each one of these cases. For this, let's do trick. Notice how it randomly selects a line here, saying you return later, knock on their door, jump out of the bushes, and scare them. Next, do we want to continue trick-or-treating? Yes, we do. And we'll knock again, and this time we'll do a treat. A treat was given and added to our bucket. That's good. Let's do that again. So we'll knock again, and we'll do another treat. And we'll continue, and knock again. At this point, we've done 3 treats. So this is what we should expect for our value for number of treats. Do we want to continue trick-or-treating? Let's do yes, and let's knock another 3 times and make this a trick instead. And we get the same value again. This is random, so that would be a 1 out of 3 chance to get the same thing. Just to see if we can get a different response, let's run this again. So we'll continue. This time we'll do trick again after we knock. So we got to knock 3 times. Then we'll do trick again, and we keep getting the same response. Let's do it again. Knock, knock, knock. Trick. We just keep getting the same response. That's very odd. I think I'm just unlucky. Let's try it again. The definition of insanity is trying these things over and over and over again. Let's try it again. Knock, knock, knock. We knock a 3rd time. We'll do another trick. And we jump out of the bushes and scare them. This is just too much. There we go. Finally, 6th time is the charm. We get you return later and place a ton of fake cockroaches around their house. So it only took 6 tries, I think. Something like that. 6 tries, and we finally got a different response. Okay, now let's not continue trick-or-treating, and we go home, and we have our candy total here, saying that our candy total is 3. That makes sense because if we look back at our history, we did treat once here, treat twice here, and then treat a 3rd time here. All the rest of them were tricks, trying to get a different trick out of here. The only trick we didn't see was this one with the drone, but your results may be different because it is random. And then we get our press any key to knock again, which is invalid because they're already home, they're not trick-or-treating. So we want to add something else that exits us out of our program. And to do that, we're going to call a built-in exit function to exit our program. And to do that, we should simply be able to call an exit function. And that built-in exit function here should exit our program. So let's go ahead and run this again, and this time we're going to press any key to knock. Let's get 1 treat, and let's do 1 trick after knocking. And then we'll say we're done. Go home. You're tired, and go home to count your candy, and your candy total is 1. This executes our exit function and now closes out of our program.